Okay, a rectangular storage container is to have a volume of 10 cubic meters. Okay, so it's like as length of its base is twice its width. So I'll put base here, and then this would be the width. So that would be, oh no, let me put width here. Oop, read that wrong, sorry. The length of its base is twice its width. So if this is the width, this one would be 2 times the width, right? Length of its base is twice its length of its base. Yes, okay. And then we don't know the height, right? That's just so it has some other kind of height. So that's what it looks like. Okay. I know the volume is 10. So volume is length times width times height. So W times 2W times height. So that gives us 10, right? And so that's 2W squared H is 10. All right, what is it they want me to minimize or maximize? They want the minimum amount of material. Okay, it has an open top. So if I'm going to find the material, so I'll just call it M for material, I would have first off the area of the bottom. So that would be 2W squared. Then, I can take advantage of the colors here. Then I would have these two sides, right? This side would have an area of WH, and so would this side. So I'd have plus 2 WHs. And then I would have the sides that are here, right? So that would be a 2W times the H, but I'd have two of them, 2WH. Wow. All right, let's see if we can simplify that a little bit. So my material will be, I can see we can add these guys together, right? So 2W squared, 2 and these and 4 of those, so 6WH. All right, I want to use this to get rid of a letter. Can you see I want to use this to solve for H? If I solve it for H, then I'll be able to substitute it in and just have W's left in my equation. All right, so let's take this and solve it for H. So that would give me H is equal to 10 over 2W squared, or 5 over W squared. Okay, so I'm going to put that right in there. M is 2W squared plus 6W times 5 over W squared. 2W squared cancel one of the W's, so I'd get plus 30 over W. So that's my material. All right, so now I'm going to make room up here. So now I want to take the derivative of that and set it equal to 0. Okay, so let's do it. So M prime will give me 4W. And here you know this is going to be negative 30 over W squared. Set this equal to 0. So 4W is 30 over W squared. Let me make some more room here. So then if I'm going to solve for W, I'm going to multiply by W squared and divide by 4. So I get that W cubed is equal to 30 divided by 4, or some same thing as saying 15 divided by 2. So W is equal to the cube root of 15 over 2. And then we could go plug that back into our H, and I guess I erased it, but I remember that H was equal to 5 over W squared. So 5, that squared gives me power over root, so 2/3 power. Whew, ugly. All right, let's see what we get next. So now we've got this rectangular field, and we're going to have some cost involved for the side lengths. Okay, so let's see what we've got here. Actually, I'll start in the next video.